Hey, so this is Rapid Prototyping with PICO-8. I'm Brett Lazier. So I'm a professional game developer. I've been a professional game developer for over 8 years. My day-to-day is mostly graphics and low-level programming, and I currently work at Velan Studios. This, however, is a personal presentation, and obviously it's not representative of the user opinions of Velan Studios. So what is PICO-8? It's this thing called a fantasy console by this company called Lexilawful. It fits somewhere between an NES and a Game Boy in terms of the actual, hardware features that it offers. It's a piece of software, but yeah. I would liken it more as a modern analog to BASIC, largely because it has this fully integrated runtime and editor. And if you visit that URL, you can get a copy of it. I think it's going for about 15 bucks right now, so very cheap. I'm actually going to run through the introduction to it live. So you boot it up, and you get this cute command line. Obviously, you can type help, and it'll tell you what the different commands are. The different pieces of it, right? If you hit escape, what'll happen is it'll go into the IDE, and the first thing that it shows you here is the code editor. PICO-8 is programmed in a subset of Lua, and important things to notice is this guy right here, the token count, because this is one of the limitations that the software imposes on you. And we'll be talking more about what kind of limitations it has. A lot of them are very willful limitations. But that's a thing to keep an eye on as you type more stuff in here. That'll increase. Something that I wish that they would do by default, but they don't, and you need to read the manual to find out, is there are 3 functions called init, update, and draw, which do exactly what they sound like. They're the basic functions that you have to have in your program in order to actually, do anything. I wish they'd pre-populate that, but they don't. So anyway, moving on. This is the Sprite Editor. As you can see, this is your palette. There are 16 colors in your palette. Black, color 0, happens to be the default transparent color. You have 4 sprite banks right here. If you notice, banks 2 and 3 are in a different color. And that's because the memory that they have is shared with the memory that the map has. We'll talk about the map in a second. Other important thing to notice are these little buttons here. These are flag bits, and you can set those, and they have arbitrary meaning. You can use them to pretty much store data that you later want to query. So, for example, if you wanted to make a bunch of different terrain tiles and have them all marked as one certain type of terrain, you might use a flag bit to denote that. So this is the map editor. You use it by clicking on sprites at the bottom and then painting them in. Sprite 0, unfortunately, is also the transparent sprite. So there you go. You can paint in it. The map is 128 by 128 tiles. Or sorry, not 128. It's 128 by 64. But the bottom 128 by 32 is shared with these sprite banks 2 and 3. So if you're going to use the sprite banks 2 and 3, you can't use the bottom half of the map. If you're going to use the bottom half of the map, you can't use sprite banks 2 and 3. They're mutually exclusive. Moving on, there's the sound effects editor. And this guy is very, very complicated, and I don't really want to get into how to use it. The general gist is that you've got 64 different sound effects that you can set up. Each sound effect has 32 notes in it. The notes have a pitch, a volume, and an instrument. And you should read the manual because this is very complicated. And then the music editor builds on top of the sound effects in the same way that the map builds on top of the sprites. And that music is made out of sound effects, and you have access to these 4 channels, and they can each channel can play a different sound effect. So again, you're going to want to refer to the manual for that. Where did this guy go? Lost my place. So something that's really cool that PICO-8 happens to have is this web player. So when you save out your cartridge, you can choose to save it as an HTML file, and you can post those HTML files to your personal website, itch.io, wherever. It's just super cool because it's HTML5 and JavaScript, so it'll run on basically everything, includes sound. So PICO-8 has a bunch of quirks because, what good is a fantasy console without fantasy problems? And like I said earlier, sprite banks 2 and 3 overlap the bottom 128 by 32 tiles of the map in memory, so you can only use one of those. If you use one and then start using the other, you will start corrupting your data because you'll be writing information over data you've already made. The numbers that you have access to are from negative 32,768.99 to 32,767.99. They're in this format that's called 16.16 fixed point. You don't need to know too much about fixed point to be able to understand this. You just need to understand that, like, if you're going to have an accumulator, you probably should reset it occasionally because it'll overflow pretty quickly, especially if it's accumulating values every frame. So you need to be careful of that. Also kind of weird, cosine and sine take values from 0 to 1, not 0 to 2 pi, like you might expect. And very strange is that the sine of 0 returns 1. Most implementations, like most C, for example, sine of 0 would be 0. So something to watch out for. All right, so we're going to talk pretty briefly about rapid prototyping. And yeah, so my approach to rapid prototyping is I usually start by identifying the most important parts of the problem that I'm trying to solve, and then start splitting it up into much smaller problems. And I'll start attacking those head on and favoring visible results. It's really important to try to focus on things that are going to give you results quickly and obviously, because that's how you build motivation. It's really easy to get yourself mired in like some weird back-end problem and then want to stop halfway through because you aren't seeing any actual results from it. So definitely favor visible things. And really big thing is to try to avoid writing too much tech because, again, we're here to prove that a concept works, not actually ship it. And worrying too much about the architecture of something is just going to muddle the fact that you're trying to prove out a gameplay concept and not some weird back-end tech thing. You should also polish opportunistically, and I'll be talking about this point throughout this presentation as I show demos. And again, this one, like favoring visible results, this one's really important because it helps keep you motivated. Yeah. So some common pitfalls to rapid prototyping: not understanding the problem, and the corollary to this is solving the wrong problem, right? If you go into rapid prototyping and you start making a thing and then realize it's not working, you want to take a step back and reevaluate what it is that you're doing. So another big pitfall is a lack of expressiveness in your tools or your engine. And this is sort of bundled in with willful image limitations, or willful engine limitations, which is really, really important to understand for PICO-8, because PICO-8, as a fantasy console, is positioning itself in this very sort of retro space. And there are limitations that have been put in place to give it a retro feel. And it's really easy to want to fight against a lot of those, but it's better to work with them and pick your battles. And along that line, there are positive limitations when you're rapid prototyping, right? So your best rapid prototyping tools are going to give you really well-rounded functionality, right? They're going to have a good set of graphics routines. They're going to have good input, sound, scripting stuff. They're going to give you fast iteration and feedback. A good rapid prototyping tool is not going to be one that you have to sit there compiling for a half hour every time you change something. But good rapid prototyping tools also aren't going to give you every single tool ever. They might give you some weird special case ones depending on the rapid prototyping tool, because there are some that are designed for prototyping specific types of things. But don't expect a fully featured engine if you're just rapid prototyping. And they're also not going to give you unlimited access to their internals. That's sort of against the point, right? You're not trying to write tech. You're trying to make a game. So in my opinion, limitations often help you stay focused, right? It's this idea of the tool being good enough for the job that you're trying to solve with it. So we're going to talk about three projects of mine that I've done in PICO-8. We're going to talk about some interesting aspects of each. The first one is PICO Wars. And so PICO Wars is a tactical turn-based war game that was inspired by the Advanced Wars series. It has no AI because I didn't want to write that. Instead, it has local two-player multiplayer. The game has 3 unit types. It has an infantry, a tank, and an artillery. And the goal of the game is to capture the enemy base. So I'm going to do a demo of it right now. Yeah, so this is PICO Wars. You've got this little cursor moving around. As you can see, it is the blue player's turn. So I can select a guy. I can move them any of these spaces on the map. They will move there. I can't go anywhere, so I have to end the turn. Move. You can attack. I can't kill them this turn, unfortunately. I should be able to get myself killed this turn. There you go. And this is not finished because I started writing it over Christmas and got sidetracked by life and a lot of other things. So this is where I am here. I feel like the stuff that I was interested in, at least for this, were pretty successful. Oh, and actually, yeah, I'll show you other cool thing. You can buy units, because why not? So, yep. Yeah. So, the interesting thing that I want to talk about from PICO Wars is pathfinding. So, every terrain type has a movement penalty, and this is set per unit type. So each of the 3 units have different penalties for movement on a specific terrain. Units can only move in cardinal directions, and the enemy units block movement. These are sort of the salient points for kind of our restrictions on pathfinding, right? The problem that we're trying to solve. My first intuition when I was trying to solve this was, Manhattan distance, right? Like, I was sitting there and I was like, this is the greatest idea ever. This is going to be so easy. And so if you don't know what Manhattan distance is, it's the distance from one grid cell to another only along the cardinal directions. It's pretty trivial to calculate, right? It's just the sum of the absolute differences of your components. This, unfortunately, doesn't solve the problem at all because it doesn't take into account any of the differing terrain costs and doesn't allow for blocking units. And I looked this up and then immediately was like just crushed because I was like, oh yeah, that's a stupid idea. I'm going to have to solve this, with a breadth first search. So with our breadth first search, the goal of this is to generate a map of distances from the unit that we're trying to move to every other grid cell, right? And it's a pretty straightforward thing. It's same as, it'd be the same as like a flood fill algorithm. You start from your unit position and you move in the cardinal directions. For each of those directions, you'd calculate your penalty for the movement in that direction. And if the cell hasn't been visited before, you'd write the distance and push it onto a queue of cells to visit. And then you would continue iterating until all the cells in the grid have been evaluated. And at the end, you'll have this nice map of distances. And it'll take into account stuff like blocking. It'll take into account things like the penalties for moving there. So we want to get a path out of this distance map. So the first thing we can note, right, is that all of our possible destinations are those that are highlighted in sort of the shaded blue there. And that's every square in the map where our distance is less than our max unit movement. Pretty cool. So when you actually want to get a path from it, it's really, really easy. And I was pretty excited by how pretty this ended up being, because basically you just start from the destination, and then from the destination cell, move toward the cell with the smallest distance value, and you just keep moving until you hit 0, and all the cells that you traverse through are your path. Ends up being like stupidly simple and really, really nice. So yeah, that's pretty much all. Huh?
The way you did that, so each cell has their own distance value that you just go
Yep.
look for.
There's a process where you go through the map first.
Yeah. Yeah, exactly. Yeah, and yeah, there's just internally it stores a giant. It stores a 16 by 16 array. So yeah. It contains the distance value. So yeah, so some implementation details. So in terms of memory, PICO-8 has 3 memory areas. One of those is the base RAM, which is 32K of space and memory mapped I/O. The user only has slightly less than 7K of space to do whatever they want with. Everything else is taken up with either the cart ROM, which is 16K, and that actually maps to the bottom 16K of base RAM, or it's the memory mapped I/O. There's also a meg of really hand-wavy Lua memory, which is there for the interpreter. You're not really supposed to exploit it, but it's there, and you should use it because it makes your life a lot easier. This is one of the areas that I would definitely recommend just kind of walking around the limitations that PICO-8 gives you, because it just makes life way easier. Yeah, I'm lazy. Use Lua memory. So the pathfinding needs a couple different tables to store the intermediate data and the final result. It actually would work out pretty well here. I could use the base RAM because each game board is only a 16 by 16 map, so you've only got 256 cells, 256 bytes, basically. Because there's no way you're going to move farther than 255 spaces. So yeah. A dungeon crawler I wrote happens to use much larger tables as a replacement for the map memory. I'll be talking about this a little bit later in the presentation. Yeah. Other really important thing you should know about Lua in general, and PICO-8 has these too because it has Lua. Are this thing called closures, and they have first-class closures and first-class functions, and I'll put up an example in a second. But the way that you want to use these, at least most of the time in PICO-8, is a way similar to how you might use a macro in C, because you can use it to reduce code size. You can pretty much declare a local function that has access to its surrounding scope, and then just use that as a way to reduce the number of tokens you have. There'll be an example of that in a moment. These are honestly useful for way, way more things beyond the scope of what I'm talking about here. So I definitely recommend looking them up. I'm going to let you kind of digest this for a bit. So this is an example of a really, really simple closure. What you can see here is we have a function multiplied by x, which takes in one value x, and it returns a function which is going to take in a value of y. That function then returns y multiplied by x. So this is a closure because the value of x, once that inner function has been returned, is no longer accessible, but that function still has it. And that's pretty much what a closure is. It's a function and the scope that has been captured around it.
This returns a function.
Yes, because in Lua you can return functions because they are functions are values in Lua. Very powerful because you can store them in tables. You can store them, I mean, anywhere in variables. Pass them to other functions. Yeah, they're effectively like lambdas, but they're everywhere. They're good stuff. So, as an example, the pathfinding distance calculation is going to happen for all 4 directions, right? The body of each direction is going to be the same code. So I was like, okay, I'm just going to abstract this to a closure, and that's what that block of code at the bottom is there. Sorry that it's just incomprehensible variables, but the key takeaway here is that 16 lines of code became 8 lines of code with significantly fewer tokens. Because everywhere that this block of 4 lines was going to be, it turned into a single call to the function and its parameters. So it saves a significant number of tokens. And yeah, you don't actually need to read it. So the second project I'm going to talk about is this thing called Dungeon. It's a dungeon crawler. It is a time-limited, turn-based dungeon crawler. It would be categorized as a roguelike. You can visit that website to categorize your own games. It has a procedural map. It's got items. It's got various enemies. In this case, there is actually only 2. But yeah, it has status effects. And of course, most importantly, it has gold. So if you notice in the bottom left, there's a little timer ticking down. And if I don't move, it will tick down on its own. If I move, well, I died because of poison. This game is way too hard, and that's the thing that needs to be addressed, is that I just made it impossible. You can't win. But, yeah. No. Of course not. So, hit a slime for 1. I'm going to see if I can get something to hurt me again. There we go. So, as you can see in the bottom right, I have blood loss, bleed, basically, inflicted on me. And the bats are hurting me. And that is a bug right there, is that the AI should not be able to move into the player. But the bat has now achieved its ultimate goal of moving as close to me as possible, which means it can't actually attack me anymore. So, yeah, bugs everywhere. So something I do want to call attention to, if you notice, is the nice little camera scroll here. For me, this fell into the category of polishing opportunistically, because I'd gotten really sick of trying to hunt down bugs in this, and I just kind of wanted to do something fun. So I was like, I'm going to do something pretty. And I made it so that the camera has this kind of sort of exponential slowdown, lerp toward you. So very nice. Anyway, it's Dungeon. Whoa, get back here. Where did you go? All right, so the thing I'm going to talk about is dungeon generation. This happens to be a really well-researched field. In fact, it's almost 40 years old. At least it might actually be more than 40 years old at this point. But I'm using Rogue as my tent pole here, stake in the ground, whatever. Choose your metaphor. But Rogue was written in 1980, so yeah, it's going to be 40 years old soon. And anyway, as you can see here, there were quite a few examples. I could actually dig up a lot more examples. And in fact, the field of roguelikes is amazingly wide. And there's hundreds of resources on the internet. I, of course, wanted to invent everything again on my own because that was the fun thing I was trying to do for this project.
What has RPI taught you?
Yeah, about that. Anyway, so let's talk about dungeon generation, right? So we've got some desired properties for what I want my dungeon to be like. So I want to generate rectangular rooms. I'd really like every room to be reachable, connected. I'd like to minimize thin hallways just because I think they're not particularly aesthetic. I'd like every room to have a minimum area because I don't want tiny, tiny rooms. Those are also pretty bad. I also require the dungeon to have a staircase up and a staircase down because that's how the game goes. You can't ever go back up, but you need to know where you came from. And the staircase down is to go down to the next level. And I'd like every room to be connected by doors because I like doors. They're neat and the player gets to interact with them. So here's the algorithm I came up with, right? So we generate a starting room right in the middle of the map-ish. We generate some doors on the edges of that room, and basically the way that I had it set up was that every wall can have at most one door of each room, basically. And then so for every single door that we've decided to generate, we might not generate all of them. We're going to generate at least one. We attempt to make a room in that direction. How we'll do that is we'll generate a width and a height and then try to fit that next to the current room. If it fails, we keep shrinking it until it fits. And if we shrink it down to a certain size and it's not going to fit, we just abandon it entirely and assume that there's already something there or it's just not going to work out. And hopefully there will have been another room somewhere that got made. If the room was successful, we'll generate some exits off that and add them to the list. Of course, we would continue iterating like this. And we keep trying to add more rooms until we hit our max room count, right? To me, at least, this seems like a pretty straightforward way to do it. You're not going to get any really interesting features. Again, it's just you're going to get these clusters of rectangular rooms, but that's kind of what I wanted. I wanted, this sort of nice, tight cluster of rooms. And yeah, so when the dungeon generation works, it really works, and you get these really nice aesthetic-looking dungeons that are like, here's your center room, very pretty, and it's got these nice rooms off it that are, they look good. Unfortunately, I'm not perfect, and the algorithm has bugs. And when it fails really bad. So if you look at the left picture, you can see that there's a weird cluster of 4 doors up there. I have difficulty explaining why that is. The middle one honestly isn't that bad, but it's just like these thin rooms. I just don't like the look of it. And then the one on the right is a complete and utter failure, and I don't even know where to begin with that one. Yeah.
I like the door that we sit at.
Yeah, like you do.
It's a closet.
Yeah. So, right, maybe I should have read what the internet had to say. Anyway, bugs. They're sad. I'll fix them someday. But yeah, so let's talk about the implementation details. The map's 128 by 128 tiles because, go big, go home. I ended up storing it as a Lua table because it would require 16K of base RAM, and you only have 6.75K available in base RAM. So it actually ends up taking up like 64K of the interpreter memory because of the fact that the numbers it contains are 16.16 fixed point, but whatever. So yeah, all the sparse objects, the enemies, the potions, which actually I don't think in my demo you saw any potions, which is sad. They're all stored in a list. The objects are all tables. They've got just a bunch of data. They're kind of like structs, but they actually do have methods on them. They have these proc, update, and on-death functions, which I'll talk about on the next slide. And most of the update logic for them actually resides outside of the object storage itself. So again, these proc, update, and on-death functions make everything in the game uniform, which I thought was really cool. The proc handles additional on-hit effects. So for example, the proc function is going to be the thing that will be called when a slime or a bat hits you, and it'll roll some dice and decide whether or not you're going to get poisoned or start bleeding. And you can actually get multiple instances of poison and bleed, and pretty much any effect. You can have multiple instances of any effect on you. So if you're poisoned like 3 or 4 times, you're going to die in like 1 turn. I don't know. I thought that was pretty cool. But so yeah, moving on. The update is the AI script or per frame logic for the thing. A lot of stuff doesn't have update if it's just like a static object. Like potions aren't going to have an update. And the on death is for things that happen when the enemy or object is destroyed. So, for example, potions are objects with 1 HP, and they use the on death for applying their effect to the player. So, like the potion that's going to apply regen to the player is going to apply that on death. The slimes and bats will actually also use their on death in order to generate the potions. They'll roll a die on death that will decide whether or not they're going to generate a potion that will drop right where they were. So I could have gotten really clever with the player because the player uses the exact same system as everything else in the game, but I'm a jerk and I special cased the player in a lot of places, so it is not as uniform as it could be. This is definitely an area where I could go back and make it very nice. But yeah. So, all right, moving on. Final project is Scanline Renderer. And I'm going to talk about this a little bit before I actually demo it. So the way that PICO-8 draws sprites and map segments is drawing the entire sprite or map segment at a time. It's effectively doing, what's called a blit. And this, honestly, in this day and age, that's the sort of thing you'd expect something to do if it was drawing stuff. But what if we actually want to emulate how the Nintendo Game Boy draws? And the way that it draws is this way. It's called the Scanline Renderer. It's going to draw 1 line at a time. The programmer is going to set what's called a background data pointer, which is pretty much going to tell it where to access the background tiles. It'd be an analog to like the map in PICO-8, right? And the programmer would also set what sprites they wanted to draw and where to draw them. At the end of every line, there's going to be something called an H-blank callback. That's the horizontal blank interrupt callback. And that's going to happen at the end of every line. And then there's a V-blank callback at the end of the frame. The V-blank callback is pretty much your update. It'd be like your per frame update would happen during V-blank. If you happen to want to know how the Game Boy renders down to very, very nitty-gritty details, I recommend watching this talk. It is the Ultimate Game Boy talk at 33C3. It's pretty amazing. Definitely worth a look if you're interested. So, how are we going to achieve this in PICO-8, right? So, PICO-8 supports masking the draw region, right? It has a clip rectangle. The function is quite literally called a clip, and you just pass in the coordinates where you want to clip to. So we're going to use that. We're also going to allow the user to set the interrupt callback and scan line to call it on. And then for every single line, we're going to check and call the interrupt. We're going to set the clip. We're going to draw the map, and we're going to draw the sprites. And I'm going to show you a really dumb thing I made in it. Yeah. So if any of you happen to know about the demo scene, you'll be excited about my extremely, I don't know, not particularly inspiring efforts toward this. But this basically is showing off a simple H-blank effect, right? So what this demo is doing is, if you notice this straight pattern here, that's the actual background data that I have drawn, and I can actually go into the editor and show you. So as you can see, we have our little colors. So this is the background data, right? And what it's doing is every frame it's calculating a sine wave, and it is shifting the background either to the left or the right based on that sine wave. This is obviously not super amazing. but it shows off pretty simply what you can do with H-blank effects, because normally you're going to draw the entire map and you're not going to be able to get a wavy effect out of it. And it's this exact same kind of thing that was used on pretty much all of Nintendo's hardware, besides like up on the consoles up to the N64 and on handhelds up to the DSi. They actually all had support for this kind of thing because they're all scanline renderers. So yeah.
So we can expect Earthbound to come out on Pico at some point, right?
I mean, you could write Earthbound if you really wanted to. I mean,
You gotta have those snazzy backgrounds.
If you could manage to get them to license it to you, then sure, you could write Earthbound for PICO-8. So.
And you just have to add in more trippy music.
Yeah. So, sadly, PICO-8 has a virtual CPU with a per frame cycle limit, and the reason it has this is so that it can be run on different platforms and pretty much ensure that any given program is going to run the same way across all platforms. Because PICO-8 runs on everything from obviously this machine and Windows, Mac, Linux, to the Raspberry Pi, and also to this ridiculous thing called it's like the Pocket Chip, I think is what it's called. It's like $49 little like single board computer that has a little chiclet keyboard on it, and it runs PICO-8. It is a significantly less powerful machine than this laptop in front of me, but you can still run pretty much everything that you can run in PICO-8 on that, and it's because of the virtual CPU. So if you happen to have noticed that number that was in the upper left corner that was like 0.56, that was how much of the virtual CPU I was using, and that was just for drawing my silly H-blank effects. So I'm doing this rendering really naively. It is eating up more than half of the virtual CPU. So for this project, some things I'd probably want to look into would be to like do range checks, so I limit how much extraneous drawing we're doing, because there's no need to draw a sprite if it's not actually within the clip rectangle. No need to even try. And if the what do we call it, the interrupt hasn't been set, we can draw a much larger block of background before we do it. Right now, I am super naively just drawing a single line at a time, and that could be way better. We could also emulate how drawing actually works on the Game Boy with BitLogic, and this is probably the direction I would go in, because it'd be fun to just play around with stupid stuff. And this would involve actually using the PICO-8 memory routines, which are surprisingly fast. So yeah. Anyway, this one was a small one. There's not much to talk about. I'm just going to wrap up real quick because we're almost done. So further areas to investigate in the realm of cleaner and smaller code. I think I could probably get a lot more mileage out of doing more object orientation. When I'm prototyping stuff, I tend to just make a bunch of global variables because it's easy, and there's probably a lot more that I could get out of going a little more object oriented, and it would also make it a lot cleaner. Should definitely make heavier use of closures. I use them quite a bit, but I could probably use them a lot more. And I should encapsulate state better. Again, global variables everywhere is not a good time. So other things that I should really get into, messing with RAM directly, because you can do some really, really cool stuff with this. And there are a lot of demos on the PICO-8 DBS that deal with like doing crazy stuff with RAM. In particular, there was one where someone was doing lighting using the RAM because they were using it to set up lookup tables for like actually shading tiles. It was fantastic. I couldn't find the link to it again, or I would have included it here. But yeah, it's definitely worth looking at like what other people are doing. Again, lookup tables, because memory access is faster than Lua table access, and that is for reasons that I'm not even going to touch in this talk. We can talk about it after if you are interested. And I should also use RAM for program storage because it's there, and maybe I should be more spirited toward what the fantasy console wants. These are really the three most important resources. I was gonna try to dig up more, but like these are the most important ones. The BBS, the bulletin board system, it's basically the PICO-8 forums. It's super awesome because you just get a ton of really crazy people posting insane things all the time, and you look at it and you're like, how in the world did this person do this? Yeah, it's super inspiring. I recommend checking that out. And everything on there runs through the web player, so you can just play it in your browser. It's very cool. The PICO-8 cheat sheet is also very useful because it just helps you get a quick overview of the API. And the manual is pretty much invaluable. That's the documentation. It's in this one file called pico-8.txt, and it comes with the software. You should read it because it's really important. So anyway, that's it. Thank you. You should go forth and make awesome things now. And then post them to the bulletin board system so that other people can enjoy them.
There's so many PICO-8 games there.
Yeah. I don't know. Does anyone have any questions?